considering these questions are as a continuation of our last video where we talked on the roots of complex numbers. Now, if you look at question 1, we said find the 3 cube roots of 8 cos 264 degrees plus I sine 264 degrees, and show the roots on an Argand diagram. And the next ones requires we should evaluate the 3 cube roots of 2 minus I divided by 2 plus I, and we can express the result in modulus or argument form, and in special order we express also the principal root in the form of a plus bi. So let's start with the first one. We want to evaluate the 3 cubic roots or the 3 cube roots of 8 into cos 264 degrees plus I sine 264 degrees. So the first thing we can do is to replicate it as z, which is 8 cos 264 degrees plus I sine 264 degrees. Now, since we are dealing with cubic roots, we can also as well change it to modulus or argument form. That's 8 argument 264 degrees. Now, the principal root, which will be according to the cube root of 8 argument 264 degrees, where our r is equals to 8 and our theta is equals to 264 degrees. And we know that if z is equals to r argument theta, then z raised to power n is equals to r raised to power n argument n theta. So therefore, our n in this case is equals to 1 over 3. Okay, so the first cubic root is z raised to power 1 over 3. So that will give us 8 following this formula. And r raised to power n, that's 8 raised to power 1 over 3 argument n theta, that's 1 over 3 multiplied by 264 degrees. So in essence, this will give us 2 and 264 degrees divided by 3 is 88 degrees. That's 2 argument 88 degrees. Now, since we are evaluating 3 cube roots, okay, that means our n is they will be separated. They will be separated by 360 degrees divided by 3. So they are separated by 120 degrees. So Z2, the second cube root, is separated from the first cube root by 120 degrees. The third is separated from the second by 120 degrees. So Z2 is equals to 2 arguments 88 degrees plus 120 degrees, and that will give us 2 arguments 208 degrees. And the third cubic root will give us 2. Third cubic root is separated from the second by 120 degrees. That's 2 arguments 208 degrees plus 120 degrees, and which will give us 2 arguments 328 degrees. Now, so we have our 3 cube roots. We can rewrite it here. Z1 is equals to 2 arguments 88 degrees. Z2 is equals to 2 arguments 208 degrees. And Z3 is equals to 2 arguments 328 degrees. So therefore, we are also required to show all the roots on an Argand diagram. So on an Argand diagram, we can display it. 88 degrees falls on the first quadrant, very close to the end of the first quadrant. So this will be Z1. 208 degrees falls in the second quadrant, in the third quadrant, which is around here. And 328 degrees falls in the fourth quadrant, which is around here. So now we have been able to display the 3 cubic roots on an Anagram diagram. And that brings us to the end of the first question. Now, if you look at the second question, it says determine the 3 cube roots of 2 minus I divided by 2 plus I, given the results in modulus or argument form. Now we should express the principal roots in the form of A plus BI. Now, in that case, we are asked to express 2 minus I divided by 2 plus I. Now, as we know earlier, we have to convert this to polar form. Okay, and to convert to polar form, we have to first perform a division operation as regarding complex number in Cartesian form. And in performing this, we have to multiply the numerator and denominator by the conjugate of the denominator. So if you don't understand what I just said, kindly refer to the division of complex number, that's the part 3 of this video. So that will give us 2 minus I divided by 2 plus I. The conjugate of the denominator is 2 minus I and 2 minus I. So this we can now multiply out to give us 2 minus I multiplied by 2 minus I divided by 2 plus I multiplied by 2 minus I. So in essence, when we open the brackets, divided by 2 into 2 minus I plus I into 2 minus I. So then we proceed and we have 4, 2 multiply 2 and 2 multiply minus I, and then we perform the same operation. So that will give us 4 minus 2I minus 2I plus I squared, and this will give us 4 minus 2I plus 2I minus I squared. And if you recall from the beginning of this course of complex number, we recall that I is equals to square root of minus 1, I squared is equals to minus 1, I raised to power 3 is equals to minus I, and I raised to power 4 is equal to 1. So we substitute our value of I squared into this and this. So this will give us 4 minus 2I minus 2I plus I squared is minus 1 divided by 4 minus 2I plus 2I minus I squared, which is minus 1. So in essence, we are saying this will give us 4 minus 2I minus 2I equals minus 4I, and plus minus 1 plus minus 1 will give us minus 1, and minus 2I plus 2I will cancel out to give 0, and we're left with 4 minus minus 1 is plus 1. So in essence, we have 3, 4 minus 1 minus 4I divided by 5, and that will give us 3 minus 4I divided by 5. So we can split this further to give us 3 over 5 minus 4 over 5I, which can also be written as 0.6 minus 0.8I. So Z, which is originally 2 minus I and 2 plus I, is also given as this. So in essence, we are saying Z is equals to, which is equals to 2 minus I divided by 2 plus I, is equal to 0.6 minus 0.8I. Now after this is done, we need to convert 0.6 minus 0.8I and convert it to polar form. Okay, and we did a lot of example in the part 5 of this complex number course. So, not to waste too much of our time, the first thing to do is to draw the Argand diagram of this complex number, and that will give us, it has note that it has positive real parts and negative real parts, negative imaginary parts. So this is imaginary parts and this is the real part. So since it has positive real and negative imaginary, we are considering this aspect. So positive real of 0.6, negative real of minus 0.8i. So in essence, this is the Argand diagram display of this. Now all we just have to do is to bring out this triangle, and remember it has an angle theta and is at right angle triangle. The distance from this distance here is 0.8 and the distance here is 0.6. You can refer to the part 5 of this course to explore more understanding on the conversion of Cartesian form to polar form and vice versa. So bringing out the triangle, we have this 0.8, we have this 0.6, angle theta, and modulus R. Now, modulus R, according to Pythagoras theorem, we give you the square root of 0.6 squared plus 0.8 squared. And the square root of 0.6 squared and plus 0.8 squared is equal to 1. And we can evaluate our theta using tan theta is equal to opposites over adjacent, and the angle facing angle theta, the side facing angle theta, is called the opposite and the other side is called the adjacent. So our tan theta therefore is equals to 0.8 opposite divided by 0.6 adjacent, and that will give us 0.8 divided by 0.6 will give us 1.33. Then theta will be equals to arctan 1.33, and that will give us 53.13 degrees. Now with that done, we can now evaluate our argument of z. Recall we are in the fourth quadrant, argument theta, and the argument of z starts counting from the positive real or positive x-axis. So our argument of z is 360 degrees minus theta because we are in the fourth quadrant. Okay, so therefore our argument z is 360 degrees minus 53.13 degrees, and this is equivalent to 306.87 degrees. Now with that done, we can now write 0.6 minus 0.8i in terms of modulus form, and which will be equivalent to r argument theta, where this theta is the argument of z. So this is equal to 1 argument 306.87 degrees. Now we can now write further that z is which was equal to 2.2 minus I, which was 2 minus I divided by 2 plus I. When we solve this using division of complex number by multiplying the numerator and denominator by the conjugate of the denominator, we had 0.6 minus 0.8i, and thereafter when we converted 0.6 minus 0.8i to polar form, we have 1 argument 306.87 degrees. Now the next thing to do is to find the cube root of this. Okay, so we are expected to find the 3 cube roots of 1 argument 306.87 degrees. So the principal root, which is the first root, will be equals to z raised to power 1 over 3, and that will give us 1 raised to power 3, like we've done before, by 1 over 3, 306.87 degrees. So this will be equivalent to 1, and 306.87 degrees divided by 3 is 102.29 degrees, and that is the first root, which is the principal root. Now since we are dealing with 3 roots, by how much are they separated? They are separated by 360 degrees, 3 roots by 3, and that will give us 120 degrees. If it is 4 roots, they will be separated by 360 degrees divided by 4. If it is 5/5 roots, each root will be separated by 360 degrees divided by 5. So we can evaluate the second root now. The second cube root is separated from the first cube root by 120 degrees. That will give us 102.29 degrees plus 120 degrees, and that will give us 1 argument 222.29 degrees. And finally the third root is separated from the second root by an angle of 120 degrees, and that will give us 222.29 degrees plus 120 degrees, and that eventually will give us 1 argument 342.29 degrees. Now with this done, we can go back to the question to see what next to do. Now they say determine the 3 cube roots, given the result in modulus and argument form, and we should express the principal roots in the form of a plus bi. Now the 3 cube roots, the 3 cube roots are z1, which is 1 argument 102.29 degrees, z2, which is 1 argument 222 degrees, 0.29 degrees, and z3 is 1 argument 342.29 degrees. Now we are required to convert the principal roots. The first root z1 is the same thing as the principal root. Now with that done, we will convert z1 to Cartesian form. Now with that done, so z1 is equals to 1 argument 102.29 degrees. Now taking a quick recap, we know that z is equals to r when z is r argument theta, then z also is equals to r into cos theta plus I sine theta, and here this is our r and this is our theta. So following this formula, we know that z1 is equal to r, that is 1 into cos 102.29 degrees, which is our theta, plus I into sine 102.29 degrees. So with that done, our cos 102.29 degrees is minus 2129 plus I, and as well our sine of 102.29 degrees is I 0.9771. Now conclusively we can open up the brackets. So Z1 will be equals to 1 into minus 0.2129 plus 0.9771 I. So Z1 is, which is the principal root, is minus 0.2129 plus 0.9771 I. So this is the principal root as requested in the form A plus BI, and these are the three cube roots requested in the form R argument theta. So with that, we have come to the end of complex number generally, and we were able to touch on a lot of things. Kindly refer to other videos, other part of the videos from part 1 down to part 9. This is part 10 for more understanding, and I pray the Lord grant us understanding. Amen.